All right, I'm going to kick us off here. So we're going to talk about a recent project that we worked on called X-Ray, and sort of our journey in trying to discover the soul of a product. My name is Pat Brown. I'm an engineering lead here with Under Armour, with our engineering advocacy team. I'm here with Kareem as well, and he's a senior manager. I like to say Kareem is responsible for bringing order to chaos, and I'm responsible for said chaos. We work on the engineering advocacy team at Under Armour, and what that team does is kind of looks both outward to other parts across the business to kind of make engineering accessible for them, as well as looks back inward and tries to work with our engineering teams to just to make engineering more fun here at Under Armour, as well as more efficient and more effective. So we're going to talk through X-Ray a little bit and kind of what that is and the journey that we took and what we learned about Neo4j along the way, some of the hurdles we ran into, as well as some of the solutions. Hand over to you, Kareem.
Thanks. So the problem that we were trying to solve after discussions with a lot of people at Under Armour outside of engineering was how do we well, first understand the product journey, and by product journey I mean here the point at which the designers and the developers design the shoe or the pants or the shirt, followed by actually building it, and then talking to the marketing and merchandising teams within Under Armour, followed by actually selling it on the site or in retail stores, and then the customer wearing it and potentially talking to customer service. And through that entire journey, there's a lot of data that's accumulated, but between these various points, there's unreliable or missing data flows. And as a result, by the time you actually get to the customer service, they actually have very limited amount of information in order to give to the customers. And I think that affects every part of this journey. And so when we talk about the soul of the product, we're saying, like, how can we get the actual soul of the product, the information that is what these products are, all the way through this in a way that maintains its original value. So we came up with X-Ray as our solution, and the idea with X-Ray was we needed a way to do two things. One, recognize that there's disparate data sources within Under Armour. In fact, all along the way, data is switching between some proprietary database into an Excel spreadsheet, into a PowerPoint, into another database, and it goes through these stages. And it's during that process where data is actually being lost. And so what we wanted to do was we wanted to actually connect to all these data sources, whatever they may be, pull them into a graph in order to do two things. One, to aggregate that information, but also to establish the relationships very clearly so that we could actually pull out even more information. And so it's not just data sources like relational databases, it's also APIs that we would get through a site like Bazaar Voice that does reviews. And then of course our connected fitness engineering arm, a lot of data is exposed through various means there. And so we could be pulling information from an S3 bucket, from an API endpoint, from a relational database. And so the talk today is about how we do that and how we make the data available.
Yeah. So we're going to just give an overview of what X-Ray is, kind of where we ended up, and then we'll talk through our journey along the way. So this is the actual schema of X-Ray. You can see we have 150 million nodes currently, 141 million relationships, and 65 gigabytes of actual data. So not terribly huge, but also still a significant amount. So you can see we have everything from kind of styles to articles. If you look closely, you'll see we have factories in there, retail data. So again, like Kareem mentioned, a big issue was how do we get that data in? But so we'll continue with the overview here. This is I'm going to show you a couple screenshots of what X-Ray is. So when you go to the homepage, you can kind of see your best reviewed searches there, your recent searches. You're going to click on any of these and actually see all of this product data. And then also we have a sort of related styles there, so that's a little bit of a way to sort of explore the tool more. Like Kareem mentioned, our first task was getting this usable by our CSRs. So the customer service reps could then go and actually see all this data, which things like the related styles, things like review data actually just was not necessarily accessible. So along the way, we did kind of run into a couple hurdles. Like I mentioned, our first big one was how do we get our data in there? So we have a lot of different sources. I'm sure if you're familiar with Neo4j and looking at some of the tutorials and blogs, there's a lot about CSV files and sort of getting up and running quickly. But we needed a way to not only pull data in one time and analyze it, but we actually wanted a production level system that we could have this data be in the database, but also be updated regularly and maintained pretty easily. So our need, like Kareem mentioned, was to pull different sources, and our challenge was different sources would sometimes actually fuel the properties of the same node. So in this case, this isn't exactly the use case we ran into, but it's similar. And so I figured it's a good example. But we actually had one product node that we needed to bring in properties from different locations. So the example here is that we have our ecom database, which maybe has a product number and a name. And then we have our development database. And so that maybe has data that hasn't been merchandised yet. So this product may not have a merchandise name on it. It does have the same product number. It does have a release date, which could be important for us to use, but it has a different ID. So we explored several different tools. Your traditional ETL, this is kind of how I thought about it. So the root in a traditional ETL, the root is very much like the source, and the outcome is configured, right? So you sort of have your data source, you tell it to do these things, transform it a certain way, put it into the data. But our concern was that this creates a lot of room for spaghetti pipelines, similar to spaghetti code, where you don't really know where things ended up, or if you're looking at a node, it may not be entirely clear where that data came from, particularly if properties have different sources. So a couple questions came up as we were exploring this. One was, how do you handle indexes and constraints? What will be our process if we decide to change our import strategy? Are we going to be repeating a lot of this data? We're going to be generating Cypher queries through a traditional ETL and putting that data in. What's the learning curve if we were to use something like Kettle, right? What's the deployment strategy across different environments? So how do we actually have a staging environment? How do we have a production environment? And then what about sort of unorthodox pipelines, right? So if we're pulling review data and it's a REST API and there's something unique about it where it's not entirely straightforward, it's not a one-to-one mapping, how do we do that cleanly in a traditional ETL? So what we wanted was a solution where the actual root was the outcome, in this case a node, and the source could be configured. So that way we can look very quickly and see this node has data coming from these places. So we wanted to create a system that was very specific to Neo4j. And so that's the approach we took, and we built something that could do that for us. So we came up with this thing we just called a data service, and that can pull data from different sources, put it into the graph database, combine properties, etc. So I'm going to kind of walk down the journey of kind of what we took as we built this thing. So we decided to add review data, right? We pull that from a third party. In this case, we have our product database or ecom database that's already working. We want to add reviews to that. So this service will then go out, pull that review data, and stick it in as a review node with maybe a rating property. That's pretty easy. Problem is, how do we create a relationship here between the two? Particularly if third-party system uses our ecom ID, but we don't actually store that ecom ID in Neo4j, right? We already did the product combination based on product number. The review doesn't have the product number. It just has the ecom ID and the rating. So we kind of took two options here. We explored those a little bit. One, we could just add source IDs to each node, right? Use this as a property. So when we pull that data in, just kind of jam the source IDs on there, and if a node has a couple different sources, it may have a couple different IDs. Problem we ran into there is, though, how do we index these, right? How do we enforce a clean naming convention? And then how do we ensure they're unique? What if we have some collisions there in terms of names? So the second option is actually to create these sort of data source ID nodes. And this is the option we ended up going with, which is a little bit of overhead in terms of data, but the kind of cleaner nature of the structure was worth it in our opinion. So these allow us to create indexes based on these data source ID nodes. They avoid name collisions. And we can also sort of abstract this a little bit. So the end user of this service doesn't need to know that there's such a thing as data source IDs when pulling in data. And so this is kind of the end result of our solution. So if we have 3 different sources for data, 2 of which are fueling product, you can see the data service will then pull from those locations. It will do its typical kind of transform and then load that into the database, but it will also create these data source ID nodes. And then, of course, if we want to create a relationship now, it's pretty easy. When we run our import, we can simply look for the data source ID nodes, follow those back, and create our review relationship from there. So a couple lessons we learned along the way, just kind of 3 simple ones. One, when you're importing data, there's a lot of different ways to do it. You can merge it all together at once. So if you have 2 nodes and you want a relationship, you can do that. You can pull that data in one query, create the 2 nodes, and then merge. One of the talks earlier was actually just talking about that. That can have some performance issues, and so we found it a little bit more effective to do 3 separate runs in that instance. So you would run once to create your first node, run it again to create your second node, and then run it the 3rd time to create your relationship. Obviously, with 2 single nodes, that's not really a big deal. But when you have a batch load in of thousands of different pieces of data, when you try to do it all in one query, what Cypher would do is actually aggregate everything together. And that's why you can even see here what we're doing is we're doing these matches and using with, because that will actually help Cypher improve that query. Second piece is use indexes. That seems pretty straightforward, but sometimes it's easy to forget that you can create indexes, it's easy to forget to do that, and then you run an import and it takes forever. That's a quick way to avoid that. And then lastly, avoid relationship properties. So those are useful, I'm sure, in certain situations. We ran into a lot where it was just easier to either A, put properties on the nodes themselves, or B, create these actual sort of like node style, almost like join tables, but nodes designed to embody those relationship properties. And a big piece to that is you can't put indexes on relationships. So it makes it difficult. Our second hurdle we ran into was time. So we did not have a lot of time, A, to build this application, and also for this project, for our own time to devote to it, there just wasn't much there. So we needed to build this quickly and prove value. So the tooling we use for this, we like to call it sort of the GRANDstack Plus. So the GRANDstack, if you haven't looked at it, I highly recommend it. It is very powerful. That's GraphQL, React, Apollo, and Neo4j. There have already been a couple talks that have mentioned that. We call it the GRANDstack Plus because we also use TypeScript and Parcel. If you haven't heard of Parcel, it's just like a front-end built bundler. But unlike Webpack or even Create React app, there's just not a lot of configuration necessary. So it's very quick to get up to speed. So we applied this tooling. Here's just kind of an overview of our architecture of what we built. We had this whole system running in Kubernetes. Neo4j is just a managed instance there. We have our typo there, but it should be data service. That's using TypeScript. Our API layer is using TypeScript, Apollo, and GraphQL. And then our UI layer is using, like I said, Parcel, Apollo, as well as React. With this GRANDstack, we had a running system up in days, and we were able to iterate on that very quickly. So if you've ever tried to put together a GraphQL server, even a REST, connecting all these dots takes a good chunk of time. So to be able to use the GRANDstack for that and get it up so fast is an incredible value add. So the GRANDstack, one of the things I just wanted to give a quick overview of that and how fast it is. If you haven't seen this or dug into it very quickly, it's almost just as easy to get something up and running. Assuming you have a Neo4j database running, right? This is all JavaScript. You can use the Neo4j GraphQL driver that exists. Create your driver, define your GraphQL schema. You augment that using the Neo4j GraphQL.js library, and then you start your server. And assuming that your database actually matches your schema, so you would, in this case, you would have a genre and a movie node in there, then it just works. It's almost like magic, but it's a very powerful tool. So I definitely recommend taking a look. A couple of things we learned along the way, a couple of hiccups. One, these things are actually undocumented to the best of my knowledge. This I found through an issue tracker. But if you are using GraphQL and you want to model your nodes or your schema just after your nodes, it's pretty simple, right? If you make that your schema in GraphQL, that'll just work. Everything's fine. But let's say you want to add images, right? And so you have this images property. It doesn't actually live in your database because maybe your images are stored in some S3 bucket and you need to do a lookup to grab the data and spit it back. So you add this to your GraphQL schema, and you try to run it using make augmented schema. Unfortunately, that will not work. Even if you have this custom resolver and all the logic is there, Neo4j will still kind of yell at you with this error. Quick way around that is just to add the Neo4j ignore directive. And Neo4j will not try to build using that images. And so it will just work for you. Another kind of helpful tip we found was just around shortcuts and creating those. So this is an example. If you just kind of go with out of the box how things work and you model your GraphQL schema exactly after what's in Neo4j, here's a front-end query where you want to get the URLs to display images for, let's say, a style, right? And if you're not familiar, a style is think of that like a product, and the article, think of that like a material. And so these materials have different images, and you want to display those. So it's pretty simple. Your front-end query, if you're familiar with GraphQL, you're saying, hey, give me the styles, give me the style number within those, the articles, give me the images, and then the URL within those. Pretty easy query. Then kind of a little bit of logic to just pull that out, right? You have to loop through each style, and then through each article, and then through each image, and then finally pull out the URL. So not the end of the world, but kind of annoying if you're a front-end developer. It's actually pretty easy to just do a shortcut, and that's with a cipher directive. So in this case, you can define the GraphQL server using, again, using that Neo4j library. You can use the cipher directive to say, hey, I actually want to just allow the developer to say, give me the images for a style. Don't worry about article and all the middle steps there. And so here you can just do a simple cipher statement to say, this is actually pretty straightforward, but if you're familiar with Cypher, you see we're just saying, hey, give me this thing that has a relationship called has article to the article. Go all the way down to the article image asset and just return the URL. And so in this case, you have this kind of shortcut now to see these other images. So that can be helpful in some scenarios. The last one is actually a pretty awesome discovery. We just kind of stumbled upon it. But the issue we ran into is when we wanted to do this related styles query, we found that we have all this data in our database, and we have a ton of styles from all different seasons, some 5 years ago, some even 6 months in the future. And so when we would do this related styles query, we pull back data that just was not relevant to the user. So we wanted to give them the ability to query or to see styles that were only pertaining to the season that they were currently looking for. And so when we tried to tackle this, I looked through, okay, maybe we can do this just, I guess we'll have to use a custom resolver, and we'll have to do the Cypher query just kind of manually. We can't really use a Cypher directive for this because we need the ability to pass in an argument, and the only arguments documented are like the filter or the order by, stuff like that. So we just kind of tried this, and shockingly, it actually worked. Again, to the best of my knowledge, this is not documented or even talked about anywhere. But in your GraphQL schema, you can actually define your type. You know, this again, GraphQL. You have your parameter here called season, and it will actually magically just work. Your Cypher directive now has access to that variable coming in, and just like a Cypher parameter, You throw the $sign on there, and it just kind of works. So the rest of the cipher isn't as important, but the piece I wanted to show, again, this is actual copy and paste from our code, is you can see, throw the parameter on and it magically just works. So that's incredibly powerful to keep your cipher query all just within the directive and not have to do, again, any of the overhead of custom resolvers. Incredibly fast. So I just wanted to spend the last little bit of our talk actually showing our UI and then showing copy and paste snippets of this is what the front end calls look like and this is what our server looks like, to show you actually how simple it is to make something like this. So again, we start with our homepage here. We have a couple things to note, right? The recent searches and the best reviewed. And so in this case, if we're looking for the best reviewed, like we mentioned earlier, we've already pulled that in our database, so we know that lives in the database. But what that call actually looks like, pretty straightforward. So we have this thing, this highest reviewed products. You can pass in a first and a min count. And as a front-end developer, I want to receive back the style number, marketing name, give me the images for that, give me the articles, and give me these reviews. So very kind of simple GraphQL query. But again, if you've implemented the GraphQL server, you can definitely look at that and go, man, there's got to be a ton going on in the background to make all that happen. And that highest reviewed product actually is maybe what, 7 lines, 8 lines of code here. But you can see incredibly simple, all using the cipher directive, literally just passing in the query to the database, doing some aggregation, doing some averaging there, and returning back the results. Another example we wanted to run through was the ordered with. So in the UI, in the very center, you can see it says orders and returns. And there we have this kind of coupled with. You can think of that like Amazon's other people also ordered this thing. So we wanted to allow our CSRs to be able to see, hey, when this product was ordered, it was often ordered with this other thing. So again, thinking, wow, it's got to be a lot to try to figure out and implement. Actually, very, very simple. Front-end query, again, very straightforward. We're calling this most often purchased with, and then we're simply asking for the marketing name, style number, and then again, the images there. All we are doing in our GraphQL schema is defining this most often purchased with and passing in a cipher statement. Couple matches, couple wheres, and that's it. So again, very, very powerful for getting up and running quickly and not having to have a lot of overhead in both building and maintaining these things. And then I wanted to show the related styles. So again, the UI here, this is kind of what it looked like. If you landed on a product page, you would have this this related styles little widget. And we have again, the front end call here, GraphQL. Nothing really new. You're still seeing that marketing name, style number, all of that. And then the back end, while longer, is still just a single cipher query. That's it. So being able to have that, to define it, to use Neo4j to that capacity proved tremendously valuable for us. If you are curious, this uses the Jacquard index, which actually, so there is an APOC, I guess, just function for that. But this is, if you're curious and reading more about how that works, we actually just pulled it right off the neo4j.com site. So that's all we got. I'm going to throw up my Hunger Games here. Feel free to ask some questions as well, and we'll hopefully address all of those for you. And so all Hunger Games, nothing too crazy, but if you are not familiar with that, you want to make sure you go to that link on the bottom right-hand corner to submit your questions there, or your answers to these questions. And I will start addressing some of the Q&A. Cool. cool. So I actually just saw, let's see, when you create the relationships, the product in the review, did you implement that as a trigger? No, we did not actually. We do those as separate runs. So, and with our data service, we're actually to actually pull in both of those. So in this example, we would pull in all the product, all the review data, and then we would rerun and kind of build those relationships. So depending on where, the example here would be, we'd pull in the product, pull in the review data in one run, and then because that review data had the ecom ID, that was sort of the link to be able to determine what the actual relationship lived on. So we would then re-pull that data in, and instead of creating nodes, we would create relationships. How performant are the cipher statements wrapped in the GraphQL schema? Actually, surprisingly performant. So because we're using Apollo and React, again, one of the nice things there is we can kind of do that perceived performance. While the queries themselves are decent, some of them, particularly the orders, that takes maybe a couple seconds. Related styles is actually pretty quick, and that's probably a second or two. But we can still load the UI and kind of lazy load that data in. And then I see, Willine, how do you deploy your GraphQL API? Good question. This stack runs all in Kubernetes. So we actually specifically use kind of a GitOps approach for, if you're familiar with Kubernetes, we use Flux to maintain different versions. So that's actually the simple way is when we merge our PRs, they will automatically get deployed via Flux. But because it lives in Kubernetes, you can also do manual deploys, but that's kind of our approach. I don't know if you had any other specifics outside of that, but that's kind of how that works. Cool. Still got a couple minutes. If anyone has any final questions, I appreciate you guys checking in and hearing about X-Ray.